Is everybody logged in yet?
Morning.
Morning. All right. 6-2 notes and pair check. Make sure that you write the title. The objective today was we're gonna solve systems of equations using substitution, and then apply to solve a real world problem involving systems. Hopefully, we'll get to that point. Go ahead and get the objective copied down. Today's date is the 2nd. Just wondering what's the eye doctor?
Yeah.
Who needs more time? Raise your hand. A little bit. Anybody else? That's good? All right. Solving by substitution. Write this key concept down. Step 1, when necessary, solve at least one equation for one variable. Step 2, substitute the resulting expression from step 1 into the other equation to replace the variable, then solve the equation. Step 3, substitute the value from step 2 into either equation and solve for the other variable. Write the solution as an ordered pair. You guys get that copied down, then we'll go over real quick. See which one you want.
Almost done. Almost done.
Okay. When we did graphing, when we graphed linear equations, how many methods did we use to graph linear equations? We used 3, right? 3 different methods, all to achieve the same objective, right? Okay. You guys remember yesterday, or not yesterday, Monday, when we went over 6-1? When 2 lines intersect, what occurs? How many solutions are there? 1. Where they meet, where they intersect, right? Okay. What happens when 2 lines are on top of each other? Many, infinite many, right? 2 lines are parallel, no solution. All right. What we're doing today is we're going to do the second method. I'm going to show you another method, okay, to help solve that or find the intercept or find the solution, okay? And substitution, just like we did on graphing linear, okay? Does everybody have that written down? Does everybody need more time? Okay. A couple of things. First step, when necessary, we want to solve at least one equation for one variable, certain level, for one variable. That's an important piece right there. Step 2, I want to substitute the resulting expression from step 1 into the other equation and replace the variable, and then solve that equation. Step 3, substitute the value from step 2 into either equation and solve for the other variable. Write the solution as a what? Ordered pair. Write the solution as an ordered pair. So we're going to try to find where these 2 lines intersect or meet up. Madison, you good? We'll come back to it here in a little bit, okay?
Okay.
All right. Okay, is everybody clear? Is everybody good? Up to speed? All right. Write these 2 problems down right here. Example 1. We're going to solve a system by substitution. Use substitution to solve the system of equations. Is one of the variables isolated? Step 1 told me to do what? Which one's isolated? Okay, so go ahead and make sure now we want to go ahead and do what? Yeah, well, let's label our equations first. A and B. Okay, so y is already isolated in equation A, right? Okay. Here's the substitution part. You guys watching? Everybody look at this real quick. I'm going to take this part right here, and since it's equal to y, I'm going to substitute it into y in the second equation. You guys see that? B? Got that look on your face.
Yeah, I got it.
Okay. You might see if I rewrite. Let's rewrite the second equation after we substitute. 2x. Instead of y, though, what am I going to put? Negative. And I'm going to go ahead and put it in parentheses. Equals what? 2. Okay? So basically, just took this part right here is the same thing as this part. Okay? Now, again, what's the whole point? What do we want to find? Okay, I still want to find my ordered pair, which has an x coordinate and a what? Can I find the x and y coordinate with the equation the way it is? Somebody tell me why. How many unknowns do you have? You got 2, right? What happens if I do this though? How many unknowns do I have now? I'm going to have eventually 1, right? Because what am I going to do with these 2? Okay, so let's rewrite it. 2x. They got a double sign here, so we need to say 2x what? Minus 4x plus 12. And that gets rid of my parentheses, right? Combine my terms. That's my next step. Subtract 12 again. Negative 10. Divide by x equals 5. Where's that go? Okay? Ready, you good now?
Mhm.
Got it? Anybody else have any questions up to this point? Okay. Am I done? What do I need to find out? Okay, so can I not use substitution again? What would I substitute this time? I'm gonna take this 5, put it in for which one? What am I trying to find, guys? So which one would I use? Use equation what? A. Why A, Madison?
Because y is already answered.
Very nice, good. So I'm gonna put 5 in for that X right there. That gives me what?
-4
Times 5, good, plus 12. What's that give me?
-20 plus 12, which is -8.
How many solutions to this system?
1.
1. What's the solution? -5, or 5 and -8, good. Yes, Justin.
What is the difference between these two? Like if you put the X in for the.
That's a great question. Would it make a difference if I took 5 and plugged it in for this X? Do that right now. Do it. Take you about 2 minutes to do it. 2 times what? Plus y equals what? What's that end up giving me? Now what? So does it matter? It does not matter. But it's, what was the whole point behind this too, when we did this? What's the whole point of showing 3 methods? One method is better than the other method, right? Depending on the scenario that I have, right? Same thing here, I'm going to show you 3 different methods. One method is better than the other method. What if both of these equations were in slope-intercept form? Which method would you use? I'd graph them, right? Graph them on a coordinate plane because they're already what you, you got what you need, right? Right here, you have one of the variables isolated, so what method would you use? Substitution. Are you with me on that? You guys with me? Okay, what if both of these were in standard form? I'm going to show you a method on Friday, so it'll work for that. Okay? All right. We'll see how you guys do. Number 1, make sure you write your answers on your cards, okay? And then put your answers in your clickers. Work that one and answer that one. I know to get stuck now.
Oops, I started on it. Okay.
Are you working this one?
Yeah.
Okay.
Actually.
Yeah, I'd go ahead and write them down. That way it's easier to see. Okay. You got that very last one, so circle that. Just circle the two now. And then you're gonna put that in for that line, I think. Okay, so rewrite your, rewrite.
And I substituted that in for.
Yeah, so you've got your 4 there. To bring 4 down too. So it's gonna be 4 times what? 2x. Well, I didn't do it on the first one, the one I worked for you guys, because there wasn't a coefficient in front of the variable. Okay? So this is throwing, this one's throwing you guys off because what do you have in front of your y right here? You got a 4 in front of it, right? So when I take this and I substitute it in for the y, what happens?
So,
You still gotta keep the 4, don't you? Yeah. So you got 3x plus 4 times what? 2x. Okay, so now what does that turn into? There you go. No, you're good. You got it. Just come on. There you go. Know how to get this by itself. God bless. Well, you gotta multiply them first. What's 4 times 2? Okay, so 3x and 8x is what? Equals. And now divide by. There you go. Okay, now can I eliminate the extra choices? After just finding the x coordinate? Alright, so narrow down your extra choices, right? Once you find x, though, there shouldn't be any problem finding y. You just gotta use, which equation did you guys plug it back into? The first one, good. Equation A? Alright, do that one. Now write the 2 equations, list them, write the 2 equations down first, alright? And then change whatever you need to change. Step 1, you gotta do what? Isolate one of the variables. Has that already been done for you? So are you gonna have to do it this time again? Yeah. Now what you have to decide is what?
which one?
You have to decide which one's gonna be the best one. Look at them both. Which one's gonna be the best one? Isolate.
I'm gonna do.
Why B?
Because all we have to do is add what to the other side instead of trying to flip everything.
That's a good choice. Well, who else said A? Okay. Let me ask you a question. Does it matter?
No.
Okay? It does not matter. You isolate whatever one you want. Here's the deal. When you isolate, like Madison's talking about B, which I would probably do B. Okay? Just because, what does it do to my numbers? After I divide it, it's going to knock them down a little bit, right? Okay, so you've got negative 4x plus 2y equals 20. Move that over there. Then what? Now you're going to use that and substitute it into the other equation, right? B, you wanna isolate, what do you wanna isolate?
Like, what do you mean?
Well, you said that, you wanted to isolate A.
Cause I think that'd be easier, cause all you gotta do is move over 3x, and then you have a negative on the y, so you change everything, off the side after that.
That is what's possible.
Great, do it,
Alright,
okay? What do you gotta do now?
divide by next.
Now, take that one and substitute it into what? That's the trick right here, you gotta keep it, all your information separated. What equation did you change?
I went ahead and did the bottom one, the first one that you did,
No, but we said, hey, if you want to change equation A, which you did, you want to isolate that one, then I gotta take that part right there and substitute it into this second equation. Okay, Madison changed the second equation, so she's got to substitute back into the first equation. Does that make sense? Okay, you're wanting to change the first equation, which is fine, you can do that. But you have to substitute it into what? The second equation. Jesse, did you have a question?
Yeah, does it matter once we solve one of the equations, can we plug it back into the same equation?
Yeah, you can. You can use any of the equations you want. Yeah, but
Okay, after I do that, now what I do? I get there, down to this.
okay, so we changed the first equation, right? Is that what you did?
Now they're both in the,
Okay, which one do you want to use? Do you want to use this one or this one?
talking.
You want to use that one? Okay, so forget about that. Okay, this is why I go way back and said you gotta label your equations, right? Okay, so we changed, which equation did we change?
Okay.
We isolated B. You said you wanted to do the top one, right?
Yeah,
Are you clear? Okay. So I'm gonna take this now, since I changed B to isolate A, I'm gonna take that and put it into what? Y for the top one. So that ends up giving me what? Okay?
There's more.
Yes, ma'am. Yeah, you did.
Yeah.
You changed the first one, okay? All right, again, what are you forgetting to put here? Oh, you did, okay, 6x, 12, I see it now.
You put the whole thing right.
Okay, combine. Oh, it's 2 times 12.
Oh, you have to multiply that.
Yeah, it's distribution, isn't it? Mm-hmm. And there's a name on that track. Okay, which equation did you change?
I changed, equation B.
Okay, so you stick it back in for Y.
Okay, now, don't forget, this is why I told you, you have to put this in parentheses, okay? You gotta put that back in parentheses, because what happens now, you gotta distribute the what? Which turns your 10 into minus 10, okay? Did you get it, Haley? That's it, you good, you stop? B?
I got it wrong.
Are you stuck?
Yeah, I can't, like, the wrong one there. I got 8:20.
We'll get the right one.
I know, I don't know, I'm trying to find what I did wrong now.
I'm stuck.
Okay, what part are you stuck on? You guys wanna work it on the board?
Yeah.
Go right now. Hurry. Race and direction, Diego. Go work it on the board. Hurry. Both
I
of you.
don't know how to do it.
Period at all?
Other than giving the equations and supplementing it,
And work your problem out.
when I'm stuck.
Take that board off there and go pick up the side. For the work right next to him. Anybody else stuck? Hazel, did you get it? You stuck too? Write your two questions down, or, go up there, Angela, raise that other part, so.
What?
Go next to Daniel, write your problem down. Okay, so you're gonna go ahead and write the revised. So you guys help them out. What is B doing wrong right off the bat?
Yeah, you forgot the two.
They forgot what?
And putting in the X or Y.
You forgot the 2 in front of the Y.
You forgot, you have to distribute the two.
What do you mean? What do you mean? You use this, you take this, right?
Yeah.
And you plug it into the second equation, right? For what?
I put in
Yeah.
What's in front of that Y? So what should be in front of this?
alright.
Now rewrite it. Simplify.
Yeah, now I'm stuck.
Well, what property is that?
Distributed.
Okay, distribute. Okay, what did Angela? Angela did the same thing that, Madison did. Look at this. What'd she do, Madison?
She forgot to keep the negative.
What's in front of the Y right here? So what can you put in front of that Y? Okay, so now when you sub, you did all right up to that point. When you sub that in for that, what do you gotta keep? Now what happens to that? That's what? So you need to raise from, yeah, there you go. Now do 3x. There you go, that girl. You're good, you're on the right track.
That's not like a.
Now what you gotta do, B?
I did negative 4.5.
What's it gotta do next, guys? Got your X, find your Y. Got your X, find your Y. You good, Angela? Yeah, bud.
The one, the negative.
Yeah, it's negative. You got a negative in front of the Y. Like, what can I put in front of the Y? It's supposed understood to be there, it's not there. I want that, so that turns into basically -1. It's the same thing as distribution. Right?
Yeah. It was something.
What's -4 times -2?
Oh.
That would threw you guys off a little bit, didn't it?
Yeah.
No, I mean, you should more. Are you good? Are we good, guys? Anybody else have a question? Who hasn't answered yet? Me. Okay. IT, sit down. Yeah. Remember now, we've been working one scenario. What scenario we've been working? For the 2 lines do what? Cross. Isn't there 2 other scenarios though? Okay, write these 2 down. Got equation A, equation B. Which variable, step 1 tells me to do what? Isolate. Which one do you want to isolate? Equation B? For which variable? So here we go. Bring this over here. If I move the X over there, that gives me what? 1x minus 2, right? Now, since I changed the equation B, I have to substitute back into equation A, right? You guys with me? For that y. Don't forget what's in front of it. We'll go 2x plus 2 times what? Good. Equals 8. 2x. Read it off to me. Yeah, but can I say plus negative?
Sorry,
Minus 2x? Do what?
-4.
Yeah, -4, good. Oh, sorry. Got more in the brain. Now what? Very good. Why is it no solution?
So because -4 is fine,
That's your statement? So it's no solution. What's the scenario then? What are my lines doing? Parallel, very good. What would happen if the left side, all your variables canceled out and your left side equaled the right side? What would happen? There would be many solutions, good. But that infinite many means what? My lines do what? Yeah, if I had 8 equals 8, then that would be what? This is no solution. That means the lines are what? Parallel. Okay, you guys think you're ready for the next one?
So if you got like 8 equals 8, like you said, that'd be infinite.
Infinite many. That's your last scenario. Or that was the middle scenario that we talked about yesterday, right? You got 2 lines. They're always going to do something. They're going to either cross, they're going to be on top of each other, or they're going to be what? They're parallel. That's what we're trying to figure out. Okay? You guys hot? Huh? Humidity. What'd you get? Hey, bad stuff? Hey, stuck?
These are the ones that I actually can do.
Did you get an answer? I saw. You said?
No, but also very emotional.
This one, this part right here, it's notoriously every year in and year out, it's one of the tougher sections. Yes, you would. Well, you got a -2, would you divide by -2? Yeah, you would. Mhm. How many of you are stuck? See, you got it? Angela, where you stuck at?
And some of them,
C and D?
not
Okay, no solution means the lines are what?
taking.
Parallel. Okay, so they're not ever gonna cross, are they? What's the difference? Infinite many means what? How many solutions are you gonna have? How many ordered pairs can work in both these equations? A whole bunch of them. That means the lines do what? They lie on top of each other. So, say, you got two rulers here, 2 lines, right? How many solutions? Because they're parallel, right? Okay. What if I put them on top of each other? How many points on those 2 lines? All the way down, all the way that way, and all the way that way, right? So all those points would do what? Would they fit in both the equations? That means infinite many solutions. Okay? So 2 infinite minis, they gotta be on top of each other. No solution. How many solutions there? 1. Okay? Now remember too, when you substitute, what do we say? The left side is not the same as the right side, and your variables are gone, then that's what? No solution. If the left side is the same as the right side, then it would be infinite many, wouldn't it? Okay? Who's still going? You stuck or you still?
No, I mixed up my equations. Like, I put half of the equation as it is, and I put the other half of the other equation in it. I just mixed up regular equation. For some reason, I got 2 or something.
Those are the same.
Oh, okay.
That should be the same.
It's like, I unconsciously considered it.
Now, yeah, you won't be able to. I'll show you a method next week that works best for this one. I just wanted to, I want you to see that you can use all these methods for every one of these equations. That's you good, or are you still working?
So,
Okay.
substitution.
Okay, now we probably won't have time. That sheet that I gave you guys, this one right here, okay, hang on to that. We'll finish up tomorrow, okay? But I'm gonna go ahead and give you your pair check so you can go ahead and get started on that, all right?
Third.
You got one?
Anybody else? You got one, maybe? This, you got one? Okay, let's look at the first two on the pair check. Okay, use substitution to solve each use system. And what would you do on this one first? That's a that and for y right there. That gives me what? Rewrite the second equation as x plus. Combine like terms. 5x, 5, then what? X equals, I'll take that 1 and do what? Sub it back into the x, so you can find what? Try the x, which is 1. So y equals what?
4.
Very good. Okay, what about on the second one? Take that, sub it for that y. Do I have to worry about distribution here?
No.
Okay, so x equals, or x plus, x minus 1 equals 3. Oops, that one. 2x equals 4 divided by 2, x equals 2. Shove that back into what? So 2 minus 1 gives me, so my order pair is going to be 2 and 1. Yeah. Which variable did you isolate?
I isolated the y. I mean the first equation.
I'd isolate the x. I mean, because it's already by itself, right? All I have to do is one step on this one. So I'm going to take that and move it over there, which gives me what? Just 2y. You guys got to click on that. There you go. I'm getting negative. All right, this. That way I don't have to divide by a negative, okay? It keeps me from doing another step. Now here's the trick though. Where am I going to substitute it into the other equation? For the x, right? Don't forget there's what in front of it. Okay, so when I rewrite it, I got to put negative 2y plus 13 in there. Minus the 5y equals 6. Simplify it now. What do you got to do?
It'll be negative 6y plus 39.
Combine like terms. Got 39 on both sides. Gives me negative 33. Divide by negative 11.
No.
Y equals 3. Now, hey, stop for just 2 seconds, or for 30 seconds. Once I found y right here, what am I looking for now? Okay, I know the y. So what would I substitute 3 into?
The first equation right
This
here.
one, or this one?
That one.
I'd use the revised one, right? Why? Because x is already by itself. Save yourself, let's work smart, not hard, right? Save yourself some time.
I'll be smart.
She probably took one over.
Yeah.
Which more? Can I send the assignment we did in here yesterday?
Can you what?
Have the assignment that we did in here?
Oh, it's over there. Actually, no, check if it's, actually, you know what? It may be over there. Can't remember what I did with them. Here's one, Jacob. Just come grab this one.
Hey, can you see that? Okay.
Sort of like, on both feet, you're standing like this.
No, can you
I did.
do it?
It,